In this video, we are going to solve few questions and prove these equations by applying both product to sum as well as sum to product or difference to product formula that we learned in the previous videos. So these are going to be few interesting questions. We will solve more in the future videos too. Please pause the video, note down these questions and give it a try yourself so that your application skills improve. Then you can come back and watch the entire video. And also please drop a comment if you know a different way to solve this. I highly appreciate it so that this channel grows and it becomes a very interactive video. So thank you for watching and let's start with the first one now. In the first question, we have to prove that cos 2x times cos 6 by 2 minus cos 3x times cos 9x by 2. So this is equal to sin 5x times sin 5x by 2. Now let's identify what format these two are in. So this is cos A times cos B. So both are of that format. So we know that the formula for 2 times cos A cos B is cos of A plus B plus cos of A minus B. So to change it to the format of 2 cos A cos B, let's multiply and divide it by 2. So we can write this as 1 by 2 times 2 cos 2x cos x by 2 minus cos 3x times cos 9x by 2. And there is a 2 here too. So let's apply the formula now. So this will be 1 by 2 times cos of A plus B. So cos of 2x plus x by 2 plus cos of A minus B. So 2x minus x by 2 minus again cos of A plus B, which is 3x plus 9x by 2 and plus cos of A minus B. So 3x minus 9x by 2. Correct? So let's simplify this now. We would have cos of 5x by 2 plus cos of 3x by 2 and minus cos of this would be 15x by 2. And the last one would be minus cos of 6x minus 9x, which is minus 3x. So cos of minus x is cos x. So this will be 3x by 2. Now we can cancel out cos 3x by 2 and minus cos 3x by 2. So we would have 1 by 2 times cos of 5x by 2 minus cos of 15x by 2. Now this is of the format cos C minus cos D. So the formula for that is 2 times sine of C plus D by 2 and sine of D minus C by 2. So this is a unique formula that we have to keep in mind. Now let's apply that. So this will be 1 by 2 times sine of C plus D would be 5x by 2 plus 15x by 2 and this whole thing divided by 2, and sine of D minus C would be 15x by 2 minus 5x by 2, this whole thing divided by 2. Now if we simplify, we can cancel out the 2 here. So we would have sine of 20x by 4 and sine of 10x by 4. We can simplify this further. This will be 5 and this will be 5 by 2. So the final answer would be sine of 5x times sine of 5x by 2. So this is how we can solve the first question by applying both the product to sum format as well as the difference to product format. So please understand these formulas by heart and we can apply those easily. Let's try the second one now. In the second question, we have to prove that this equation is equal to 0. Basically sin alpha plus 2 pi by 3 plus sin alpha plus 4 pi by 3 this is equal to 0. Now let's consider this to be sin C plus sin D, which has a formula of 2 sin C plus D by 2 times cos of C minus D by 2. So let's apply that. So we will have sin alpha plus 2 sin C plus D is alpha plus 2 pi by 3 plus alpha plus 4 pi by 3, and this whole thing divided by 2, and cos of C minus D would be alpha plus 2 pi by 3 minus alpha minus 4 pi by 3, and this whole thing divided by 2. So in the second part we can cancel the alpha, so we would have sin alpha plus 2 times sin of here it would be 2 alpha plus 6 pi by 3, this whole thing divided by 2, and this would be cos of minus 2 pi by 3 divided by 2. Now let's see if we can simplify anything. So in these two we can reduce this by 2, so we can have sin alpha plus 2 sin of we would have alpha plus, and if we cancel, so this is 2, so this will be alpha plus pi, and this will be cos of pi by 3. Now let's apply the value of cos pi by 3. So we'll have sin alpha plus 2 times, now sin of pi plus x is minus sin x, so this is minus alpha times 1 by 2. We can cancel this out, so we would have sin alpha minus sin alpha, which is equal to 0. Let's try the third one. In the third one we have to prove that cos alpha plus cos beta the whole square plus sin alpha plus sin beta the whole square, so this is equal to 4 cos square alpha minus beta by 2. So we can consider this to be of the format cos C plus cos D the whole square, and this to be sin C plus sin D the whole square. So let's apply that. So cos C plus cos D the whole square, so let's apply this as 2 cos of alpha plus beta by 2 times cos of alpha minus beta by 2, and this whole square plus sin C plus sin D, we can apply the formula, and this will change to 2 sin C plus D, which is alpha plus beta by 2, and cos of C minus D, which is alpha minus beta by 2, and this whole square. So here we applied cos C plus cos D, which is cos C plus D by 2 times cos C minus D by 2. Now let's square this, so we would have 4 times cos square alpha plus beta by 2 times cos square alpha minus beta by 2 plus 4 times sin square alpha plus beta by 2 times cos square alpha minus beta by 2. Now we can consider 4 cos square alpha common between these two, so we would have 4 cos square alpha minus beta, cos square alpha minus beta by 2 as common, and this would be cos square alpha plus beta by 2 plus sin square alpha plus beta by 2. Now this is of the format cos square x plus sin square x, which is equal to 1. So this changes to 1. We would have 4 times cos square alpha minus beta by 2. So this is how we can apply the trigonometric identity as well as the sum to product formula and solve question number 3. Let's try the fourth one now. In the fourth one, we have to prove that cos alpha plus cos beta plus cos gamma plus cos of alpha plus beta plus gamma, this is equal to 4 times cos of alpha plus beta by 2, cos of beta plus gamma by 2, and cos of gamma plus alpha by 2. So here we have CosC plus CosD plus CosE plus CosF. So if we consider this, let's group these two together. So cos alpha and cos beta we can group together so that we can apply the formula of CosC plus CosD, and cos gamma plus cos of alpha plus beta plus gamma, we can consider this as another grouping. So let's apply that formula now. So cos C plus cos D, the formula is 2 cos C plus D by 2 and cos of C minus D by 2. So we are going to apply that now. So this will be cos of 2 times cos of alpha plus beta by 2 and cos of alpha minus beta by 2. That's the first part. And the second part would be, we are applying the same formula for this. We would have 2 times cos of gamma plus alpha plus beta plus gamma divided by 2. So this is the first part. And cos of gamma minus alpha plus beta plus gamma, this whole divided by 2. Okay, now let's simplify this. So we would have 2 cos alpha plus beta by 2 and cos of alpha minus beta by 2, and this will be 2 times cos of, we would have alpha plus beta plus 2 gamma divided by 2, and the last part would be cos of gamma would cancel out. We would have minus alpha plus beta by 2. So cos of minus x is cos x, so we would have alpha plus beta by 2. Now we have cos of alpha plus beta as common, and 2 is also common between the two parts here, so we can take it out. This would be 2 cos of alpha plus beta by 2 and cos of alpha minus beta by 2. We fix this, plus cos of alpha plus beta plus 2 times gamma by 2. Now this is again of the format cos C plus cos D. Let's apply the formula again. So we would have 2 cos alpha plus beta by 2 times 2 cos alpha minus beta by 2 plus alpha plus beta plus 2 gamma by 2, this whole thing divided by 2, and cos of C minus D would be alpha minus beta by 2 minus alpha plus beta plus 2 gamma by 2, this whole thing divided by 2. Okay, now let's simplify this. So in the first part, we can cancel the beta out, and this will be 2 alpha plus 2 gamma by 2 and then divided by 2. So we can simplify this to 2 cos alpha plus beta by 2 times 2 times cos of 2 alpha plus 2 gamma by 2 divided by 2. And the last part would be, we can cancel out alpha here, so we would have cos of minus 2 beta minus 2 gamma by 2 and this whole thing by 2. So here cos of minus x is cos x, so we can consider it to be we can consider minus 2 to be a common value. Let's simplify this further. So we would have 2 cos of, so 2 times 2, we can change this to 4. So we would have 4 cos of alpha plus beta by 2 and can cancel out the 2's here. Cos of alpha plus gamma by 2. Similar way, we can cancel out the 2 here and the negative sign would change to positive because cos of minus x is cos x. So this will be beta plus gamma by 2. So this is the proof for question number 4. It's basically application of algebra and these formulas. We just have to be careful when we solve these long equations, and then we can prove this easily. So thank you so much for watching till the end. Please share this video with your friends. These are unique questions that will help you to improve the skill in solving trigonometric functions. Thanks again, and I'll see you in the next video.